Hello and welcome to the Endless Studios video series on basic computer science concepts. We've talked about how computers can execute code like a set of sequential instructions, one after the other. You can think of the path program takes when it executes as if the execution were flowing like water from one instruction to another. In fact, computer scientists refer to the way a program's execution moves like this as control flow. In a simple set of real-world instructions like a recipe, control flow is linear. It proceeds in a straight line from the first step to the second to the third, and so on until the end. One of the things that makes computer programs so powerful is that the control flow doesn't have to be linear. Programming languages support two fundamental concepts to handle other kinds of control flow scenarios: choice and iteration. For this video, let's focus on choice. Often we only want an instruction or series of instructions to be followed under certain circumstances. Programming languages give developers ways of writing code that can take this into account, known as conditional statements, or simply conditionals. The most basic conditional structure is the if-then statement, also just called an if statement. The concept here is pretty straightforward. We tell the computer that if a condition is met, then execute some code. In C#, we can do this by writing the keyword if, then a pair of parentheses surrounding our condition, then a pair of curly braces surrounding whatever code we want to execute when the condition is met. Let's talk a little more about the different parts of this conditional statement. In C#, whatever is inside the parentheses after if is called the conditional test or logical test. When C# encounters a conditional test, it asks itself, is what's inside these parentheses true? If whatever's inside the parentheses turns out to be true, then whatever code falls inside the following pair of curly braces, known as the then statement or the consequent, will execute. If, on the other hand, whatever's inside the parentheses doesn't turn out to be true, i.e. it is false, then the code inside the curly braces will not execute. In this case, the program skips over everything inside the curly braces and proceeds to execute the next instruction following them. The logical test must always resolve to a true or false value. If you remember our different types of variables, you might think this sounds a lot like a boolean, and you'd be right. Boolean variables are often used as the logical test in an if statement. There are lots of uses for using if statements that execute code only when a certain condition is met. But what if you want something to happen if the condition is met, but if it's not, you want something different to happen? Fortunately, there's another keyword for this: else. The else keyword can follow an if-then statement, and the code inside the curly braces of the else statement will run instead of the code in the body of the if statement in cases where the if condition is not met. Basically, you're telling the computer, if this, then do this, otherwise do that. No matter which one executes, the program will then go on to execute the code following the else statement. Let's say we're making a game where a player must be above a certain level to receive a quest. They can get the quest if they're at least level 5, but if they're below level 5, let's have the NPC tell the player that they can't take the quest. So after the if statement, we can write else, then put the code we want to run inside another pair of curly braces. It's even possible to put an if statement inside another if statement. This is called a nested if. By nesting ifs inside other ifs, you can add even more layers of complexity and detail to your conditionals. So as you can see, there's no limit to how much complex behavior you can create with conditionals. Mastering conditional statements gives programmers the freedom to make code that adapts to all kinds of different scenarios the player might encounter.